Welcome to EDU 3339, Chapter 15, Fraction Concepts. So the first thing that we need to understand about fractions are the constructs, and there are several of them. A most important one is the part whole, that a fraction is a representation of part of a whole. We always put the whole on the bottom, that's what our denominator is, and the part on the top, that's what the numerator is. Usually, the part, the numerator, is the smaller of the numbers, but not always, because if we have an improper fraction, it will be the larger one. When we're looking at part whole, we might find a sample problem such as the one on the right. There are 40 apples in a bushel at the farmer's market. 3/4 of the apples are Macintosh. How many of the apples are not Macintosh? And in this case, the students would need to find how much 1/4 of the apples are, which are not Macintosh. And we would do that generally by seeing what the whole is. The whole is 4/4. They need to understand the whole. And then what part of that is. If we know that there are 3/4 Macintosh, then we only need 1/4 left, and that's what's not Macintosh. A lot of work needs to be put into understanding the part whole. It doesn't come easy for kids, and a teacher needs to spend some time with manipulatives on these types of problems. The next fraction construct is that of measure. Now, this really deals with how much rather than how many. Like part whole deals with how many. So this is more of how much, and it uses a measurement piece usually. So in this particular example, how long does the pencil measure? So it measured 1.5, I would assume maybe inches. But things could be asked like, how many sections of a half are represented? So in this case it's 3. It's 3 halves. So they could understand that they're measuring still the numerator is the part, 3 of the halves, 2 is the bottom, so that we can see it's more than 1. The next fraction construct is that of division. This is very, very important. The students understand that a fraction represents division, and this is sometimes difficult for them to see if the larger number is not on top. In this case, I'm going to show you one that is. Sharing $10 with 4 people. So there's our $10 basically that we would have with 4 people. It's not in the visual, but you would split that first by dividing each of the dollars, just like you would a division problem, and you would come up with, after your exchanges, $2.50 each. So money is a great way to start this particular construct of division. In the example on the right, basically is about cookies. 4 friends want to share 3 cookies that are left over. So we have the 3 cookies, so we're going to divide them each into 4 parts because there are 4 friends. Then we figure out that that really means 3/4 or 3 divided by 4, and that's our answer. Each person gets 3/4 of a cookie. That might be hard to divide, but that's the answer nonetheless. The next fraction construct is that of operator. It's when the fractions are used to indicate an operation, and usually we talk about this when we talk about multiplication, because of in math generally means to multiply. And here are some examples of word problems with multiplying fractions. Underlined there, 3/4 of the money. Of means multiply. So 3/4 of $60, or 60 times 3/4. And then we would multiply straight across and get our answer. Right now, the important thing is not learning how to multiply, it's learning how to understand that when we hear the language, that a fraction could represent part of another number. The next construct is ratio. And it's basically when a fraction does represent a ratio. You can look at the example I put for you. There are 25 students in a class, and 10 of the students are girls. What ratio of of the class are boys. So that would be 15 to 25 is how we read that, or 15/25. Now if we said, what is the ratio of girls to boys, then that would be 10 to 15, or 10/15. So it depends on what you're asking for when you talk about the ratio. But still, a fraction represents a ratio. So now let's look at the concept of fractional parts. You got to understand that kids can really struggle with this, and they struggle with this if the whole parts are not the same size. We understand that 1/2 of a pizza is 1/2 of a pizza no matter what its size. But children struggle with that if you have a small whole pizza and a large whole pizza. They don't understand that half of the small is not the same size because it's relative, but it's half of that small pizza and half of the large pizza. But it's a very hard concept when things are not the same size. Therefore, I recommend when working with fractions to use fraction strips or fraction bars because everything measures out to the same length. You start with a whole, like the red strip that's on the right, and then you make a strip that cuts them in half, and then those in thirds and fourths. These can be purchased at like a teaching store, or I always had my students make them because I think there's value in them creating the individual parts and seeing how each basically relates to the whole. And then I would ask questions like, let's take 2/3. So they would take 2 boxes of the light green or the bright green there, and I would say, are there any other fractions that equal the same amount? And of course they come up with 4/6 or 8/12. And they can see that that is exactly the same size because they look at them and they line them up. So I would recommend using fraction strips to help with the concept of fractional parts. That leads us to equivalent fractions, which I just gave an example of that. But as you can see, using the fraction parts in the picture on the top left is very, very simple for the students to see what actually is equivalent and what that means. They have a difficult time because the denominators get larger. It just means you have to have more parts, so the numerator has to get larger. But students have a difficult time because they've always believed that the larger the number, the larger the size. And in this case, in fractions, that's actually the opposite. So you can use fraction bars. You can use Lego pieces. That's always fun for the kids, a different type of manipulative to show that. Circle fractions or fraction circles can be used, and there's 2 examples of them there on the right. They're a little more complicated for students to understand than the fraction bars because it's difficult to use more than one of them. And in what I've seen, students have difficulty when it gets into a fraction that's over 1. So, but they certainly can be used to compare, just like fraction bars. And then as the students get really good with the manipulatives and seeing that, then you start working into things like what's on the bottom left, and that is fill in the missing part, either denominator or numerator, based upon the equivalent fraction size. And there we teach our students that whatever you do to the top, you do to the bottom, or whatever you do to the bottom, you do to the top, something like that, so that we can get those equivalent fractions. Eventually, we can go into teaching them to cross multiply, but again, that is just a shortcut, and if they don't understand this concept of the fractions being equivalent, learning to cross multiply is just going to mess them up in the future. Then we have comparing fractions, which fraction is larger or equal to. That goes right hand in hand with equivalent fractions. So look at the picture in the middle. This would actually be a question that might say, order the fractions in order from greatest to least, or something like that. One of the things that can be done is to really get the kids to understand what half is and how you get more than half. How do you know if a fraction is more than half or not? And what I told my students was always look at the denominator. So let's look at the one on the left. It's 4. What would half of 4 be? It would be 2. And so I know right away that 3/4 is larger than a half because 3 is larger than 2. So I'm going to go to the others. All right, 6. What is half of 6? 3. Ooh, so I need to place 2 6 on the right side. Now I don't know where yet, but I know it goes on the right side of the half. Same with 5/12. And then I just have to figure out with 2 6 and 5/12 which one is smaller and which one is larger. And that we would probably use common denominators for. So I've attached some videos to this session in the portal, and you're going to be looking at manipulatives for fractions and deciding on what fraction of the shape is read. You're also going to be looking at a 4th grade teacher who gives some 3rd grade kind of formative assessments to her students to see where they are with their understanding of fractions. Up at the top right, you'll be visiting a teacher who teaches the understanding of fractions through real-world tasks. And then there's a 4th video that just basically reviews some fraction equivalents using some models. So that will help to solidify your fraction concepts.